Now we want to go the other direction. So we want to make some equations from a graph. And we're looking for what is the red graph. So the blue is our original here. So we have a base of 4. The first thing that I would look for is, has the asymptote changed? So in this case, it looks like the asymptote is still occurring at x equals 0. So that tells me there is no horizontal translation. And that's a pretty good starting point. The other thing I'll notice here is that my x-intercept has not changed. And because of that, I know that it hasn't been a horizontal translation, or sorry, horizontal stretch, or a horizontal translation as well, that it's in the same spot. And it's probably not a vertical translation either. So then really we're just left with a vertical stretch in this case, as far as just how, besides the fact that it appears that it's been reflected. So I'm going to compare these critical points that they've kind of given us, which is the nice thing about this. So if I look from this point to this point at the height, I've got a height difference of 3 here, height difference of only 1 on the blue graph. Horizontally from these key points they're giving us, or critical points, we've got 3 as a distance, and we still have 3 as a distance. So again, they're trying to give the hint here, no, this has not been horizontally stretched. So we've just got this vertical stretch, and because we're looking for the red one, the red one seems to be 3 times bigger. So I'm going to have 3 log base 4. Now we have to deal with this reflection. It is in the x-axis, which means that's going to be a negative a value. So it's going to actually be negative 3. So y equals negative 3 log base 4 of x. All right, our next one, same thing. My first thought is, where's the asymptote on this? Well, they're both the same. It hasn't changed. So again, I'm not looking for this point to have been moved from here to here, or in this case, because we're going from blue to red, the other direction. This asymptote being the same says, no, it's not a horizontal translation, so I can't just say it's been translated over 4. Now again, they're trying to give you a hint with what these are based on these 2 points. They want you to compare. So if I look at the vertical distance between these points, well, it's 0, so it hasn't been shifted up or down. Now, so then I'm going to go to horizontal stretching it then. So from 0 to 4, we've got a height of distance of 4, and then from 0 to 8 is 8. So it appears that the blue one is twice as big as the red one. Now the red is our new graph, so that we're going to say that as it's half of the blue graph then. Now when we actually go and put that into our equation, that means our b value is going to be reciprocated, so it's actually 2. So then we get y equals log base 8 2x. Let's just do one more example. Again, our blue graph is our original, red is our new graph, and I'm using the same strategy. Has that asymptote changed? No. So that's not going to be a horizontal translation then. Has the x-intercept changed? No. So it's not going to be a horizontal stretch. It's not going to be a vertical translation. They've also given us some key points to kind of look at. And I looked at the horizontally, these are in the same location. So again, probably not a horizontal stretch. So I'm going to go do a vertical stretch then. Let's compare. So from 0 to here we have 1, and then from 0 to our blue graph it's 3. So it appears that the blue graph is 3 times taller than the red graph. Now the red is our new graph, so the other way of saying that then is the red is 1/3 as big. Now with vertical stretches we don't have to reciprocate. It doesn't appear that there's any other reflections or anything. So then we're just going to have y equals 1/3 log base 2 in this case of x.